This is Algebra 1, Semester 2. This is a unit called Equations Review. It's the fourth lesson within that called Every Number is a Fraction Practice. It's on creatormath.com, or you might have to, if you're Googling it, you might have to type in creatormath.weebly.com to find it. Okay, sorry about that. Hope you can get to the page. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.weebly or .com in this case, all right? So just to model that, where are these notes? Let's see if I can show that quickly. There we go. Okay, so here's the website, creatormath.weebly.com. Here's what the home page looks like. Right here. All the comp book stuff is down below here under the picture and the words composition book. All right, look there for that. But we're going to go for notes, videos, vocabulary, and problem sets. So this is Algebra 1. Here's all the vocabulary in this PDF. We're going to go past that. We're going to Semester 2, and we're looking for unit number 5. So equations review, and we're on lesson number 4, I can see. So 1, 2, 3, 4. Every number is a fraction. Here's the pages that these notes go on in your composition book. Please don't use this video for the correct pages. Go to the actual table of contents during the time you're watching this, because trust me, by the time you watch it, it's going to be probably different. So if we click notes right there for number 4, sometimes I have to open it a couple of times. Right there, I saw it flicker, so this one's been enlarged. So this is kind of an unusual concept, but students have so much trouble with fractions that every year I try to give them a lesson called I teach them about a rule called the 3 invisible ones rule. And the idea is that there are ones all around the numbers we deal with. And therefore, if you have a 5, and it's really 5 over 1, it's a fraction, all right? It's a little bit of a bend on definitions, but not enough that I don't think it's crazy. And it will help students start to think more about numbers. If every number is a fraction, they can deal with a number, then they're really not that bad at fractions, right? So number, fraction, numerators, denominators, vocabulary review. Almost all students know these positions and what they're called. Maybe they've forgotten them or mixed them up. Numerator is the upper position, denominator is the bottom. Invisible ones, I'll go through that. What a mixed number is, what an improper fraction is, what the middle position is. I love this one. If you have 2 and 3/4, the 2 is in the middle position. What the heck is that middle position called? All right, so with that in your composition book on the correct pages, let's go through these problems quickly. Is the number 5 a fraction? Well, since it's 5 over 1, I say yes. All right, that's all we're going for here. And it's just an understanding that if you have an x, is x a fraction? Yes, it's x over 1. Isn't every number over 1? It is, so every number is a fraction. Is the number 3 a fraction? Yes, 3 over 1. Is the expression x to the caret 2, or x squared, is that a fraction? Sure, it's over 1. Why not? X squared over 1 is a fraction. Okay, what's the power on the number 2? What is the power on the number 2? Oh, so say you have a 2 right here. Does it have a power? It does. It's to the power 1. Every number has a power. X is, if they just show x, it's to the power 1. So there are invisible ones, and I call it the rule of 3 invisible ones. So how many invisible ones are there in an x? If you have an x, there are invisible ones here. It's to the power 1. A 1 times it, and a 1 divided by it. There are 3 invisible ones around every either variable or number you deal with. So there are 3. 1 times x to the power 1 divided by 1. Given the number 5, is it in the numerator position or denominator? Well, since it's 5 over 1, it's in the numerator position. Numerator is on top. Numerator. It's the denominator. I remember D for down. Denominator is down here. So, interestingly speaking, every number you deal with, if you've just got a 5 sitting there, it is in the numerator position. And if you can start to think that way, it'll help you understand fractions when you get to those and how they sort of relate to all the other numbers and variables you've been dealing with all along. Given the number 3, what number is in the denominator position? 1. Because it's down here. Okay. Given 2 1/4. This is so 2 1/4. This is a mixed number. Mixed number. Why? Because you have a number sitting here like this and this fraction, right? I would argue to you the 2 already is a fraction, so what you really have is 2 over 1 times 1 over 4 possibly, right? Or at least this is in, and 2 over 1 and 1/4, right, is the way I would say it. I wouldn't go times, I'd go and, all right? Just like 2 1/4, 2 1/4, right? That's really what's happening. That's really what the 2 is. The 2 is also sitting in the numerator position right here. Given 9/4, it is an improper fraction. Anytime the number above the one below it is larger, the numerator is larger than the denominator, it is an improper fraction. Given 9/4, this can be spoken as, yes, 9 divided by 4. We also can write it 9 divided by 4. Right? That's another way to write. We could also write 9 divided by 4. This is divided by, this is divided by, and you literally says divided by. That's literally what this fraction bar says, right? 9 divided by. Given 2/3 plus 5x equals 20, how can the 3 in the denominator position be removed? Well, we're in high school now. We're a little bit more advanced, so they're going for an equation solving. So if you have 2/3 in an equation plus 5x equals 20, and this is a review unit, so that's why this is appropriate here. If I multiply the whole thing by 3 over 1, that would multiply 3 here, 3 here, 3 here, each term. So 3 times 2 is 6 over 3, and 3 times 5x is plus 15x equals 3 times 20 is 60, right? But I don't want to write 6 here. I would write 2 times 3 and leave it like that. And therefore, I can cancel the 3's out. And now what I really have is 2 plus 15x equals 60. I like that much better. So by multiplying through by 3, it goes into a 3 right here, and then I can cancel 3 over 3, and I no longer have a denominator in this situation. So multiply all terms by 3. Given 6, how many invisible ones are there? 6. It's divided by 1, it's times 1, it's the power 1, 3. Given a fraction, the line between the numerator and denominator is called a fraction bar, and it literally means divided by. Divided by is how you speak out the fraction bar. So if you have 2/3, it's literally 2 divided by 3. Given the mixed fraction of 5 and 3/4, the 5 is in what position? It's still a 5 over 1, you guys. It's a numerator position. So it's like saying 5 over 1 and 3/4, right? Because when you say 5 and 3/4, that's how you speak that out. You would speak out 5 and 3/4 just like this. All right, this match up the title. This is Algebra 1, Semester 2. It's 05 unit called Equations Review, and it's number 4 lesson, Every Number is a Fraction, practice on creatormath.com under the Algebra tab. Hope that helps.